Today we're going to continue our lesson with section 10.1 on sequences and series. Today I want to focus on writing the formulas, given some information. So we could be given a sequence and be able to find the recursive and explicit formulas. Likewise, we can give the explicit and you can be able to find the recursive or the sequence. So let's go ahead and look at an example where we give you the sequence and we ask you for the recursive and the explicit formulas. Notice in example 1, we give you the sequence 1, 8, 15, 22, so on and so forth. We can find the recursive and the explicit formulas given that information. So recursively, most generally, it's easiest to find the recursive. If we look from 1 to the next, what are we doing? What do we get? How do we get from 1 to 8? We add 7. 8 to 15, we add 7. 15 to 22, we're adding 7. So a recursive formula, each term is going to take the previous term. So remember, our general term is a of n. The term before that would be a sub n minus 1. And we're going to add 7 to that. We also have to tell us where we start. Our first term in this case was 1. And we're also going to put the restrictions on it that n has to be greater than or equal to 2. This simply tells us that we're always going forwards. We're not going to be able to go backwards. Explicitly, what's happening? Well, if I add 7 to each term, I know that's a linear function. So we know that a sub n is going to be some type of linear function. In a linear function, we have a slope, which is the change from term to term. So that's going to give us our 7n. Well, what happens when we multiply each term by 7? So this here, again, is our first term. We multiply it by 7, we get 7. Here, our second term, if we multiply it by 7, we get 14. Our third term, multiplied by 7, we get 21. And our fourth term, multiplied by 7, gives us 28. To get from 7 to 1, 14 to 8, 21 to 15, and 28 to 22, I subtract 6. So my explicit formula is a of n equals 7n minus 6. In example 2, we're going to give the sequence of 10, 17, 26, 37, so on and so forth. And we're going to ask the formulas for the explicit and recursive. Well, explicitly, what's happening? Well, we add 7, or recursively what happens? We add 7, then we add 9, then we add 11, and I'm going to guess then we're going to add 13 to get to the next term. So our pattern, we're always adding 2 to the difference before. So 7 to 9, we add 2, 9 to 11, we add 2, so on and so forth. Since the difference of the differences is constant, we're going to have a quadratic form. So explicitly, I'm going to think of my quadratic numbers. Well, my quadratic numbers are my perfect squares. So I have 1, I have 4, 9, 16, 25, so on and so forth. As I notice, I go from 1 to 4 to 9 to 16 to 25. That matches up with my 10, 17, 26 if I start at 9. Well, how do I start an explicit formula at 9? Well, if I move this over 2 terms, I start at 10. Or I can get my 9 into 10. So I'm going to add 2 to my number and square it. So now I'm moving over 2. This gives me my 3, my 4, my 5 squared, and so on and so forth. Now I'm starting at 9, 16, 25, 36. I can simply add 1 to each of these terms to get my explicit formula. Recursively, it's a little more complicated. And a lot of people have trouble finding the recursive formula. We will, in later sections, be able to come up with a formula to come up with the recursive formula. So if you don't quite get the recursive at this point, it's not major. We'll give you some tips and some techniques later on. But some of the easier ones, not too bad to find them. So what do we do recursively? Well, we have our a sub n is going to equal. How do I get from 10 to 17 to 26 to 37? Well, I'm adding 7, then I add 9, then I add 11, then I add 13. So I'm going to take my previous term, and generally we always do something with the previous term because it's recursive. And what do I do with that? Well, what do I notice if this is the term of 1 and 2 and 3 and 4? Well, if I multiply this by 2, why do I multiply by 2? Because I kind of have an idea of what the answer is going to look like. So if I multiply this by 2, I get 2. If I multiply this by 2, I get 4, and then 6, and then 8. How do I get from 2 to 7, 4 to 9, 6 to 11, and 8 to 13? I'm multiplying that by 2, and I add 5 to it. So I have my previous term, then I'm going to multiply the number term that I have by 2. So that gives me my 9 plus 2. And then adding 5 to that, I end up with 9 plus 7. Or sorry, 10 plus 7 gives me my 17. And then 17 plus my 9 gives me my 26. Where a sub n, my first term, is going to equal 10. And again, I know that n is going to be greater than or equal to 2. Again, play around with the recursive formula. If it doesn't come to you quite yet, that's not a big deal to me at this point in time. Example 3, we're going to give you the recursive formula, and we're going to find the sequence and the explicit formula. So the sequence shouldn't be too bad. We're going to start at 3, and then what are we going to do to it? We're taking that previous term, and we're going to subtract 4 from it. So if I start at 3 as my first term, my second term will be taking the first term minus 4 from it. So I'm going to get a negative 1. Continuing to subtract 4 from the previous term, I get negative 5. Then I get negative 9, negative 13, so on and so forth. There's my sequence. My explicit formula, well, how do I get from 3 to negative 1 to negative 5 to negative 9 to negative 13? I'm subtracting 4 from each of my terms. So my explicit formula is going to be a linear function. And in that linear function, my common difference, or my slope, is going to be negative 4. Now if I take that negative 4 and multiply it by n, again, this is my first term, I get negative 4. My second term, I get negative 8. My third term, I get negative 12. My fourth term, I get negative 16. So what do I do to negative 4 to get to 3, negative 8 to get to negative 1, negative 12 to negative 5, and negative 16 to negative 9? Well, I'm adding 7 to it. So my a sub n is going to equal negative 4n plus 7. Finally, we'll give you example 4, where we give you an explicit formula, and we're going to find the sequence and the recursive formula. Well, my sequence, I know my first term. I'm going to plug in 1 for n. So I'm going to have 2 times 3 to the first. So my sequence is going to be 2 times 3, which is 6. My next term, if I multiply 2 times 3 to the second, here I get 9 times 2. I get 18. My next term, I have 2 times 3 to the third. I have 3 to the third, which is 27 times 2, gives me 54. And finally, we'll do one more. 2 times 3 to the fourth. 3 to the fourth is 81. Times 2 gives me 162. And so on and so forth. My recursive formula, well, what do I do to 6 to get to 18, to get to 54, to get to 162? I'm multiplying each of these terms by 3 to get to the next term. So a sub 1 is going to equal 3 times the previous term, where a sub 1, my first term, is going to equal 6, and again, n is greater than or equal to 2. And that's going to end our explanation with given a formula or a sequence and finding the other two pieces of information.